Let's dive into the onion. It's one of the most common ingredients in the world, but here's the thing. It's not just one ingredient. Depending on how you treat it, you can completely transform its flavor, creating a whole spectrum of culinary possibilities all from a single bulb.
So how is that even possible? Well, we're going to break down the 6 distinct flavor profiles an onion can have. We're not just talking about how to make them, but the actual science that makes each one unique. This is about moving beyond just following steps and starting to cook with real intention.
To understand any transformation, you gotta have a baseline, right? So let's kick things off with the powerful and honestly, often misunderstood raw onion. We need to get into the chemistry that gives it that characteristic sharp bite.
So that unique sensation you get from a raw onion, it has a name: pungency. Now, this isn't a taste like sweet or sour. It's a physical feeling, a mild irritation caused by these specific sulfurous molecules. And here's the key: it's a quality that only the raw state of an onion has.
What you're seeing here is the reaction at a cellular level. Inside every onion cell, you have these precursors called sulfoxides just sitting there. But the moment you cut the onion, you rupture those cells. That mixes the sulfoxides with an enzyme called alliinase, and boom, you get a cascade of volatile sulfur compounds. Those are the very things that give onions their iconic aroma and, yeah, make your eyes water.
And here's the cool part: you're in complete control of this reaction. You can literally dial the intensity up or down by playing with 3 variables. First, the type of onion you use. Second, how finely you cut it. More cuts mean more broken cells and a bigger reaction. And third, time. That pungency is at its absolute peak in the first 10 minutes, and then it starts to mellow out.
Okay, so what happens when we introduce our first agent of change, a simple acidic environment? This is what takes us out of the sharp world of raw onions and into the bright, tangy profile of, say, pickled onions. And just look at this comparison table. It's a complete overhaul. The acid doesn't just add a sour taste, it fundamentally rewrites the onion's entire profile. The sharp aromas are toned way down, the texture softens up, and, most importantly, that physical pungency, it's completely gone. All right, now for the main event: heat. And this isn't just one simple process. It's a cascade of overlapping physical and chemical reactions. The beautiful thing is, you control the whole show with just 2 variables: temperature and time. So instead of thinking of these as 4 totally separate things, it's way more useful to see them as points along a single flavor continuum. You can stop anywhere along the spectrum to get exactly the result you want, moving from mild and sweet all the way to smoky and incredibly complex.
Let's break down the 6 specific changes, both physical and chemical, that happen when you start heating onions. Understanding these reactions is the absolute key to mastering every single level on that heat spectrum.
First up, the most straightforward one: evaporation. Onions are about 90% water. As you cook them, that water boils off, and the natural sugars that are left behind become incredibly concentrated. This, right here, is the main reason deeply caramelized onions taste so intensely sweet. Now, as that water leaves, the onion's actual structure starts to change. Heat begins to dissolve the pectin. You can think of it as the glue holding the cell walls together. This is what transforms the texture from crisp to tender, and if you go long enough, all the way to a completely jammy, spreadable consistency. At the same time, the aroma is completely changing. Those aggressive, pungent sulfur compounds from the raw onion, they're really volatile and they just break down under heat. They actually transform into new, sweeter, and more savory smelling compounds that create that rich, rounded aroma we all know and love. Now, once enough water has evaporated and the surface temperature gets above 140 degrees Celsius, the Maillard reaction kicks in. This is a reaction between amino acids and sugars, and it creates hundreds of new, complex, savory, roasted aroma molecules. It's also what's responsible for that beautiful golden brown color you get on sautéed onions. Get the temperature even higher, and a whole separate browning reaction starts up: caramelization. This one doesn't involve amino acids at all. It's just the direct breakdown of sugar from heat. This reaction layers on these really distinct notes of butter, toffee, and nuts, which are super prominent in deeply caramelized onions. And finally, at the very far end of our spectrum, you get pyrolysis. This is basically controlled burning. It happens when you hit the onion with extreme heat and there's no moisture left. This process creates char, and it adds this powerful, smoky, slightly bitter edge that you just cannot get any other way. So, now that we've gone through all those reactions, let's just pull back for a second and look at the matrix we've built. We can now see exactly how to produce specific flavors with intention. It's all about knowing which chemical reactions you want to bring into play. This matrix is your cheat sheet. It shows you exactly how each cooking method uses a different combination of reactions. Sweating? That just focuses on evaporation and cell breakdown for a mild sweetness. Sautéing brings in the Maillard reaction for savory depth. Caramelizing pushes almost all the reactions to their limit for maximum complexity. And charring? That's all about harnessing pyrolysis for a smoky finish. This is how you go from just following a recipe to actually directing the flavor yourself.
And really, the big takeaway here is that understanding the why behind what's happening empowers you to be a better, more creative, and definitely a more consistent cook. It stops being about just following instructions and turns into this fascinating process of controlled chemistry.
So remember, next time you step into the kitchen, you're not just assembling ingredients. You're an applied chemist. You're directing a whole series of reactions to build complex, incredible flavors right from the ground up.
And of course, this way of thinking doesn't just apply to onions. This framework of deconstructing an ingredient through its chemistry can be used for almost anything you cook. Which leaves us with one final thought. Now that you've mastered the onion, what are you going to deconstruct next?